Okay, we are finishing formulation, okay? Finally, we are at the end of our path. Okay, salts, for example, CaCO3. We are starting with the systematic name because it is easier. It takes a minute. I will take a minute explaining it to you. In systematic name, remember, in English, the name of the metal, yeah, then we have calcium. Now, the number of oxygens with the word oxido, trioxido, and we finish with the element in the middle, finishing 8, carbonate. And that's all. Imagine we have the reverse. For example, we have the compound that is barium, now bis, the oxido bromate. We do here. Well, we do just the same. Then barium, we write barium. Now bis, this bis, and a word between brackets means that we have brackets here and 2 because of this bis. Now deoxido bromate, BrO2, deoxido bromate. In Spanish, bis, dióxido, bromato de bario, trióxido carbonato de calcio. Okay, it's very simple, the systematic name. What about the traditional name? This time is different because in traditional name, here we need to calculate the oxidation state of the element in the middle. You remember I told you yesterday? For example, imagine today we have this compound. Then we say +2 of calcium, -2 from oxygen, then this is +2. +2 means in the acids it was carbonous acid, in the salt is carbonate, because O is transformed into it. And ig, imagine it was carbonic. Carbonic is transformed into carbonate. But as this is carbonose, +2 is transformed into it, carbonate. Then this is carbonate. Sorry, we are in English. Calcium carbonate. Imagine we have, for example, a compound with manganese. With manganese is the most difficult because it has a lot of oxidation state. For example, AM, CO3, and here we have 2. Okay, then we say manganese. Manganese is +2, +3, +4, +6, and +7. Theoretically, we have to check which one of these 5 different oxidation states is the right here. Then we take all of them and we say number of oxygens 3 times 2, 6 oxygens. That's to say -12. Okay, -12 for all of them. Then we start with +2, for example. -12 +2, 10. 10. As we have 2 chlorines, 10 divided 2, 5. Then oxidation step 5 belongs to chlorine. Then the usual is that this be the correct name. We are checking with 3. With 3 we have -12 +3, 9. 9 is not divisible by 2. 4 -12 +2, 8. 8 divided 2, 4. 4 is not an oxidation state of chlorine. Then we eliminate 4 too. -12 +6, 6. 6 divided 2, 3. 3 is an oxidation state that belongs to chlorine. Then we have 5 and 3, 2 possibilities here. Then we need to know which one is the right one. For example, this order, -12 +7 is 5. 5 divided 2 is not divisible by 2. Then in this example, we have apparently 2 possibilities, +2 and +3. If this happens, this is the most difficult, we need to do both acids. Then one of them is very similar to the anion, the other no. Then if we start with the chlorine, 5, and we do the acid plus water, we get finally HClO3 after simplification. And if we do the same with the other, with 3, we have the other acid that is HClO2. Then, as you can see, the first is the one that has the same anion than the salt. The salt is ClO3, the same anion. Then the oxidation state 5 is the right here. Then at this 5, the acid was chloric. Then the salt is chlorate. That's to say, manganese chlorate. Clorato de manganeso in Spanish. It's not usual that we have two oxidation states that give us right oxidation state for the central element. Usually that here in this first calculation we had only one right. Then we have the name just with that.